we are talking about water work. Now we will talk about the equation of the water work. Please consider this structure. For example, we have fixed sand beam with different concentrated load. Let's say P1, P2, and P3. And we can assume a mechanism like this. Okay, this assumption mechanism, assume mechanism. So we assume the plastic hinge at here and here and here, M1 and M2 and M3. Because plastic hinge occur, then M1 equal to MP, M2 equal to MP, and M3 equal to MP. Then we assume the deflection at this section is delta 1, and this section is delta 2 at the middle at this point. And the displacement here is delta 3. And we also assume the rotation here, theta 1, and here the rotation is theta 2, and here is theta 3. So we have a different set. And now, the important is water work, equation of the water work. This is the equation of the water work. This is external work and equal to internal work. Okay. The set of load or the strength of the section is called equilibrium set. Okay. The set of the load or strength of the section the strength of the section and or the load, then this set is called equilibrium set. Okay, and the set of displacement or the rotation is called the displacement set. Okay, so this set and this one, all of the deflection, displacement or rotation is called displacement set. So in the water work, we have to determine first what is equilibrium set and what is displacement set. Okay, if we have equilibrium set and displacement set, then we can apply the water work method. Okay, then from now on, please remember this equation. It's not difficult, right? It's simple. So as I mentioned, this is external work and this is internal work. So what is external work? External work is the load multiplied by the corresponding displacement. Okay, then that is external work. External work is induced by external force multiplied by the corresponding displacement. Okay, that is external work. Internal work induced by internal force. For example, moment multiplied by the rotation, corresponding rotation. Okay, so now you understand what is external work and internal work, and you also understand how to determine the external work and internal work. Okay, and the meaning. So external work induced by external force, internal work induced by internal force. Then we also use displacement set corresponding to the, the force that we used. Okay, that is important, and I hope that from now on you understand how to determine external work and internal work. The interesting point here is that you can develop equilibrium set and this displacement set dependently. Okay, dependently. That is a very interesting point of virtual work method. Okay, again, you can develop equilibrium set and displacement set independently. It means equilibrium set and displacement set are not related. I will explain in detail later when you see the example and you understand why. But that is very important and that is very interesting and powerful things of the virtual work. That's why it is called virtual. Okay, it is called virtual. So work is work. You know, work is work. And virtual work, virtual mean the equilibrium set, and displacement set is dependent each other. That is very interesting point of this approach. Okay. The next is sign convention. In virtual work method, you have to remember the sign convention. For example, if we have a frame like this, okay, we have frame like this, and the sign convention is that the moment and rotation causing tension on the side of dotted line here. So inside structure, okay. Then we call that is positive moment or positive rotation. Okay, positive moment or positive rotation cause tension in the inside, okay, in the dotted line here. So if the tension is outside, then that is minus. Okay, that is, so inside is plus. The tension inside is plus. If the tension outside is minus. Very simple, right? For example, if we have a moment curve, moment diagram, then moment inside is tension inside. Tension inside is positive, so it's plus. If the tension outside, okay, outside means the opposite side of the dotted line, then it is negative, okay, minus. It is for moment. About rotation, it is for rotation, okay. In this case, because this rotation make the inside compression, under compression, okay, then it is minus. In this case, this rotation make the inside tension, then it is plus. It is plus, okay, positive. In this case, also inside compression, then minus. The inside tension, then plus. Okay, so simple, right? So from now on, you remember this sign convention for moment or for rotation. Okay, in developing the equation, that is sign convention. Application of waterwork methods. The waterwork method has 5 major application. Okay, waterwork has following 5 major application. The first application is of waterwork is obtain. The waterwork can be used to obtain the geometrical relationship of mechanism motion by summing appropriate equilibrium set. Okay, I will give you example to understand this concept, this application. But the main is relation, okay, or geometrical relation of the mechanism motion. The second is waterwork can be used to make a moment check for a given mechanism by assuming appropriate displacement set. Okay, and the third application of waterwork is to prove the uniqueness of safe, unsafe, and safe theorem. Okay, the fourth application of waterwork is to use can be used to obtain the boundary solution. Upper bound load factor in analysis problem and lower bound plastic moment in design problem. Okay, that is bounding solution, not boundary, but bounding solution. Okay, bounding solution. The fifth application of waterwork is to calculate the deflection and the collapse load. Okay, so that is 5 main application of the waterwork. Okay, now we are going to see an application of waterwork, illustrating the waterwork concept by example. This is we call mechanism method or work method. Okay, example. Let's consider the fixed sand beam with concentrated load here, 1/3 and 2/3 of the length. Okay, then this is analysis problem. Mean what is P? P as a function of MB. Okay, so for example, we assume we know the MP of the structure of the section. Then what is P as a function of MP? That is analysis problem. How to use the work method or mechanism method in determining the load, plastic ultimate load. We assume mechanism 1. Now we assume mechanism. We assume mechanism like this. Okay, so we assume the plastic hinge occur at both ends and at the point that the load of the load. Okay, then this is mechanism 1. We assume. Then with this mechanism, we assume the displacement here, rotation here is theta, and this rotation should be because of the geometrically relationship. Then we have this rotation is 3 divided by 2 theta, and it is half of theta. Then also this displacement is L 1/3 of L theta. We assume this theta, then other value is a function of theta. So now we have equilibrium set, that is PC, and MP here, MP here, and MP here. Okay, we have MP, that is equilibrium set. The displacement sets are theta and 3 divided by 2 theta and half of theta, and this is displacement. Okay, so we have a different set, mechanism set and displacement set. Here we go. External work. External work equal to external force multiplied by displacement here and here. How about internal work? Internal work equal to MP here multiplied by theta. This one. Then this is MP multiplied by this rotation here. And multiplied by MP. Then plus MP multiplied by this one. Then it equal to this. Okay, in this case, you don't care about the sign convention. Okay, no problem with sign convention now. Next, maybe next step, I will show you when you need to consider the sign convention. But in this case, sign convention may be neglected. Just calculate the virtual work. So external work here and internal work here. Then, because external work equal to internal work, then we have this is external work and this is internal work. So what is unknown? PC. Here is P, okay? Then we have P is a function of MP. Then the solution now of this solution corresponding to mechanism here is 9 MP over L. Okay, so the solution corresponding to this mechanism is PC equal to 9 MP over L. This is correct solution because we know it is correct mechanism. Then it is correct solution. Because it is simple problem, no problem. Okay, so now we assume with another mechanism, and we know wrong mechanism. Okay, try with wrong mechanism. So let's see how. Now we assume this mechanism. Then you understand here. Okay, we also have uh, um, mechanisms set and displacement set. And now we develop the external work and internal work. Okay, then because external work equal to internal work. Okay, can you follow me? External work. External work now and PC multiplied by this one. So if we assume this mechanism, then it is theta, then it should be theta, and this angle should be, because it's at the middle, then 2 theta, and this displacement is 1/3 of L theta. So that's why we have external work equal to this one. That is external work. Okay, and internal work. Internal work now here is MP multiplied by theta, MP multiplied by 2 theta, and as its hinge MP multiplied by theta. Then we have 4 MP theta, and this one is here. External work equal to internal work. Then by solving this equation, we have PC equal to 12 MP over L. So compared to the previous value, we found that this is bigger than the correct solution, right? Bigger than correct solution. It means if we use the work method, then if we assume with the wrong mechanism, then we will find the upper bound solution. So U mean upper bound solution. Upper bound mean if we select a wrong mechanism, then the solution will be higher than the correct solution. Okay, higher than correct solution. That is important. If we use the work method and we assume with correct mechanism, not this one, the previous one, okay, if correct mechanism, then we have correct solution, okay, correct solution means PC. But if we use the wrong mechanism like this, then solution, okay, solution should be greater than the correct solution. Then that's why we use upper bound solution. Okay, do you understand? It is important. Again, if in the short word, if we use work method and if we determine the solution, then if it is wrong solution, then it should be greater than MPC. And if we assume with correct solution, correct mechanism, then that is correct solution, and that the correct solution is the lowest value among the different solution correspond to different mechanism. Okay, so maybe because this this is a very simple structure, then we have only two mechanism. You can do with different mechanism, then we can observe with different solution, and every solution should be greater than the correct solution. Okay, then this is upper solution or upper bound. Okay, upper bound solution, or it is unsafe solution for analysis. Okay, it is unsafe solution for analysis. Please remember. So if we use the work method, we can observe a solution, but it is upper bound solution, then it is not safe for analysis problem. However, we can observe the solution. Okay, so how to know it is? So because it is a very simple problem, but if let's see, let's think about very complicated problem structure. You cannot easy to know what is correct mechanism or what is wrong mechanism. It's not easy in case of complicated structure. Then how to know it is correct mechanism? Okay, that is problem. Because this problem is simple and you know really, but in the very complicated complex structure, how do you know which one is correct mechanism, which one is wrong mechanism? Then we have to check. Okay, then we have tool to check what is wrong mechanism and what is correct mechanism.